Okay, hi everyone. We are continuing a design review of the foreign function interface functionality for the compiler for Orphan Language. All right, where had we got to last time?
Right. So, last time was a little disorganized. I mean, we had sort of several different things we were talking about and so on. So there have been a few things from last time that I've implemented, and then there's sort of a list of sort of design decisions to talk about after that. So first, just quickly. So the first thing is I made sort of this promoted this sort of load external library mechanism to be sort of a bit more prominent. So it's a bit cleaner now, and it's actually exported. And then now there's this foreign, instead of create and call foreign function, there's just foreign function, which takes, the library, the name, and the type, and produces a foreign function object, which you can, call with.
That's super cool. Okay, hold on. Let me ask a question here. The load external library thing, isn't there a load? What other functions are there with names similar to that?
Well, the most similar is LibraryLoad. And in fact, actually, there's a section below, or one of the design decisions below. I think the first one has to do with this. So I mean, basically, right. So basically, the observation is this flow is almost identical to LibraryLoad and library function load. Like library function load has basically the same signature, except that it takes its type signature a bit differently. And of course, it has a much more restricted set of types it can take. And the library is specified with a string. So basically everywhere in the system, in sort of the library, find library, library load, library unload, etc., those all work by referring to libraries by strings that represent their paths. Right. And secretly on the inside, it has sort of a library pointer. But right. So one option would be to try, I mean, this requires a little bit of a small amount of kernel stuff. But one option would be to try and connect this to that mechanism so that you just put a string here, just like you would for library function load, and it will sort of tie in with that mechanism.
Right. I mean, why not let it interoperate between strings and the and these objects if it can? I mean, if it can't resolve the string, tough luck.
Right, but I think that would be as an alternative to this, right?
Well, I thought we discussed.
Go ahead.
Sorry, I mean, you were interested, Christopher, and I think this makes sense in the idea of having some symbolic object like that external library form. I think we discussed the idea of having a 2-argument form of LibraryLoad where the second argument would specify, yeah, exactly, something like give me back an external library handle instead of just a file path. So it'd be a backwards compatible way of adding this functionality to the most similar existing system function.
Right, and then I guess if we supported this, then we would also support, well, so 2 things. So the first thing is if we supported this, we'd also want to be able to take this library object or whatever it would be called. We'd want to be able to accept that inside of functions like library function load. And then we'd also want to be able to, right, and then this would presumably take both a path like library function load does, or this library object.
And I assume the library object always has a path as its, I mean, maybe, I don't know, you could imagine, for example, in cases where like the compiler has JITted something that's not in a file. I don't even know if that makes sense to represent with this mechanism, but I would imagine for the most part, these external library objects are one-to-one compatible with a path, right? Like virtually every library is a path on your computer somewhere. So the path is just a shorthand for the object.
Well, kind of. So the only case that doesn't exist, although I'm not sure how safe this case is there's basically a thing called like the RTLD default or something like that, which is basically the library handle that you use when you just want to load it like from the ether, like from the process, and you don't have a library handle, basically.
You mean where there's a byte array and the byte array is going to run against the RTL?
No, where the library is already linked in to the kernel.
Right. It's where the library's been linked into the kernel, and when the library was linked in, it was linked in with this kind of global option, which is the one that we use for LibraryLoad, by the way, which just sort of spews the symbols into the process.
I see. So that you can access pieces of the library that were not hooked up to the way that it was hooked up when.
Exactly. And it might not be obvious what the library is called. If it's like the C runtime library or something. It's
exactly right.
Well, where are we
that's-
going to define those? Are we going to have documentation for those somewhere, or what are we going to do?
Well, I mean, I think it already, like, for example, if I do this, I think this will work. Someone tell me this takes a double, right? Not a float, I think. So if I
I think
the heck is that?
So-
What is going on there?
So this is loading. There's a function called cosine in the C standard library. Every
Yep.
process, has this linked into it. So I'm just opening this. I'm just getting a function pointer for the function called cosine and calling it.
But how does it know what the base library is? I mean, how does it know?
This is loading it. So if you don't specify a base library, so in the one below, I gave it an external library object. In this one, I didn't. If you don't, it uses this, again, it uses this thing where it basically loads from the process, from the sort of global namespace.
So
of
wait a
the
minute.
process.
So is there something else like OpenSSL? Is that loaded into the global namespace?
Yeah, it is usually. I'm not sure. It's not a good idea to rely on it, but I have some examples that do stuff like that.
Right. And I imagine matlink functions as well are things that are just built into the kernel's default dynamic
How do you
library.
do discovery of what's built in, of what's available?
I don't really know. My impression is that there
I
are
don't
good
think-
discovery mechanisms.
I don't think that exists. That's not a feature of.
Well, unless it was known at the time of loading. I mean, what caused those things to get loaded into the kernel?
Because they were statically linked, or they were link time, not
I see.
runtime linking. They were build time.
But then
link.
at build time, we could in principle produce a manifest. We could dynamically build documentation at build time.
Well, I think it's very
Yes.
hard. Like it's like every library that we statically link in, you'd have to go into the documentation, find all the symbols that
That's
it
horrifying.
includes, and I don't think there's an automatic
Yeah.
way to do this.
It's a,
Really.
Yeah, and
it's
the
a
thing is,
job for
e-
ChatGPT. Go read the documentation, extract
And or just
Yeah.
make up a bunch of fake functions half the time, or yes.
yeah, right.
Yeah.
Okay.
And just to be clear, I mean, I think it's not necessarily a problem to get the symbol names. It's the types that are hard. And without the types, it's not very useful.
I see.
Right.
Yeah,
Fine.
that's all true.
So in the case of cos, if you typed, ABC instead of cos there, what would it have done? Just error it out?
I think it should just say $fail, although it should give. Oh, that's a real one. It should. Yeah, there we go.
Yeah.
It should give a better error message. But yeah, right now it just fails.
Why doesn't it make a failure object that is a
Clearly.
It should.
no, but
Yeah,
it
it should,
eats everything failure object. How the failure object applied to 5.6, what should it do?
Well, normally failure object applied to 5.6, it'll look for a key in failure called 5.6, which is sort of unfortunate.
That's pretty unfortunate.
Right. I mean, so yeah, it'll be possible to make a good failure object though, because there's this DL error mechanism where you can get like a string that explains why it failed.
Right.
Um,
That's better. By the way, I thought about that more. That's better in a failure object than a message because it's unwashed text coming from the dynamic library subsystem on your computer, which isn't really, I don't know how often we do that, but it's a bit unwashed. If you see what I
Well, so I think the best way to handle that would be if there is a meta message that says there is a message,
mean. Yes.
and
Yeah, that's,
go look in the failure object to
Yeah.
find what it is.
yeah.
Okay.
Right.
All right. So let's come back to I want to come back to this name load external library and its relationship to LibraryLoad, which seems a bit fraught to me.
Right. So they're fundamentally, to just explain what LibraryLoad is doing again, because it's actually kind of, there's a lot of secret stuff going on inside of LibraryLoad. LibraryLoad is doing something very similar to what this external library, load external library is doing. The only difference is that when you call LibraryLoad, right, you see that I applied to this and it returns a path. It just, what it did is it loaded this and it got this is secretly just a pointer, right? And this got that same pointer. And then what it did is it put it into a hash table with this path as the key to the hash table. or
I see.
to the key to that entry. Okay. So now anywhere that I use this path or this thing, which will resolve to this path, it will secretly get this same pointer.
So is our idea
and
to
it has
deprecate
one
library
nice
load?
feature.
Yeah, go ahead.
Well, okay. One nice feature of doing it this way, actually, I mean, this way is a little bit weird, but one nice feature of it is that when you write library function load and you give it a path and then, a function name and so on, if the library is loaded, it can look in the hash table and it can, extract it and everything. But if the library is not loaded, then in principle, it can load the library, which means that you wouldn't ever have to say library load. You just give it these, calls to library function loader here, foreign function, and only when they're actually used does it need to library load, which is kind of nice.
Hang on a sec. LibraryLoad is also useful for loading dependent libraries. So if there isn't a cyclic circle of dependencies, you don't have to bother with, library paths and things like that. You can just do library load on the dependencies and then load the actual library you want with like library function.
But I don't understand the auto loading mechanism. If in foreign function, we supported a string as the first argument, as the extended first argument, and it had the same behavior as library load, then that would achieve that same sort of ergonomic convenience. Yeah.
So, but so if we did it that way, or sorry, Connor, were you going to say something? Or?
Well, I just wasn't sure because from the way you're describing this, it sounds like you're hinting at maybe you don't agree with combining library load with load external library, but I also don't, in your description, it doesn't sound like I'm just a little confused about what your position is.
The place I'm going is, can we deprecate library load? Okay.
Yeah. Right. I'm not really sure, right? I mean, I think that the thing is I think we can, I think, right. The simplest thing is just to only use the path mechanism. So just screw this, external library object. Right. I mean, that
doesn't seem right to me. I mean, look, why not the following thing? Why not forget library load? It's load external library. Then load external library can take a, I'm sorry, that one at the top, the example where you had demo lib equals, that's using a path, correct?
This is using, you can call it a path. I mean, it's a thing that you can feed to find library, which will get resolved to a path.
It's not quite a path because it's not even a proper file name. There's no extension to it, you see.
Okay, fine. But then if that was a file name, with the .so extension and so on, then it could load just like library load does.
Yes.
And return an external library. I think the returning of a string seems pointless to me. And then,
the reason that you'd return this, the reason it returns a string right now is that what you do is you write, demo lib equals this, and then when you write this here, this will be a string, which is what this expects, and it will just look up into the hash table and get that result.
Right, but why not allow foreign
function the way it does
to take either a string or an external library object?
Sure, yes.
Yeah, I mean, it seems to me like I think deprecating library load wouldn't really make sense because conceptually these things are already very similar. It's just a question of, do we want to have an external library object or not? And if we do, I don't think we need a whole separate library loading function. I mean, one question, library load, the syntax of that string argument is the same, right? It can either be a library name without an extension, it could be with an extension, it could be an absolute file path. And it looks up relative to $library path. Does load external library look on $library path?
It just calls find library. So yes.
Okay. So they're semantically, they're already almost identical. It's just the question of, do we have a new return type, which could make sense. But if we do have a new return type, I don't think it fundamentally changes anything because we just support that new return type anywhere that you can currently use that string argument.
Exactly.
Right.
But so, okay,
right.
Bottom line here is anybody in, the deprecating library load, turning it into load external library and having the flow as we've discussed it. Does that make sense?
Well, I don't know why we would move it. Well,
We can't have
see. So you're
functions
saying
running around that. We can't have one thing called LibraryLoad and another called load external library. We have to
no,
make
right. Unless we have a second usage of LibraryLoad, like this library object thing. But that is also a little bit like, I mean, if we had that second usage, but actually you never need to use it because everything is compatible with the first usage, no one will ever write.
Right, but it's also,
object.
I object to the idea that there's one thing called LibraryLoad and another thing called load library.
Yeah, right. There can't be. Yes.
Yeah.
I mean, and to me, deprecating one like LibraryLoad, that's a widely used function, relatively speaking. I mean, it seems unnecessary churn to deprecate it just to change a return type, where that new return type doesn't even offer very many advantages. So to me, it makes.
Well, what do we mean by deprecate? I mean, the fact is, we can.
Well, you say you don't want to.
No,
right?
I understand that, but continuing to have LibraryLoad work for the foreseeable future, but just having a thing saying this has been deprecated, use load external library instead, seems fine to me. I mean, we're not going to change
this is why I'm a little, why I'm somewhat sympathetic to the argument of just only use these strings, because given that we have, basically the point is we have this existing system that's widely used that we can't get rid of using the strings, that isn't that bad. It would be better if it used something like this external library object, but it's not like a disaster.
Well, doesn't external library have the ability to have other properties that you could query from it?
Well, first of all, query from it is not super useful because you could query them from a string just as well, right?
Well, not with just property as
not with sub-values. Sure. I don't really know of any properties
because basically there's no discovery mechanism for any of these libraries. You can't find out what's going on easily.
Yeah, I think, yeah. So one other, maybe just to add one other complexity to this. So, right, given we're talking about maybe, unifying these or how these interact, another question is how library function load interacts with this, right? Because, right, I mean, obviously these do totally different things. I mean, this loads a library link function, which has a very specific form and everything like that. And this loads a general function from a dynamic library. And this has all sorts of things with math link connections, and this doesn't, and so on. But they have the same argument structure, and their names in some ways kind of mean the same thing.
Explain again why they're different.
Okay, so library function load.
Yeah, go. Yeah.
Well, okay, library function load is for loading library link functions. Library link functions have a fixed signature where every library link function expects like an M argument object in the first argument, and then a whatever in the second argument, and whatever in the third argument, and it returns a M result or something like that, right?
You have to write the library interface in a certain way, in a special way.
Right. So it's a not very foreign function. It's a
homely function.
At least it's at the embassy or something like that.
Yeah, something like that. Yeah.
Right. But so it's right. And there are also versions where it takes a math link and right.
It's very tied to our system. It's not, you've done something intentional if you're using that. Whereas foreign function is very much you're out in the wild. And I agree that I think it makes sense that these are separate functions because the use cases, the performance characteristics are very different.
So foreign function probably would supersede. Why would you bother with a library function?
Well, partly because you have legacy code.
Other than legacy, obviously legacy, but new projects.
So what does library function load return?
It returns a library function with a name very similar to foreign functions. And library functions right now, there's opaque objects. There's we don't say anything about what's inside them. All you can do is you can call them.
Do they have a summary blob or not?
They do. And so, right. And actually, in fact, in compiled code, when you use library function declaration, which based on some of this stuff, maybe should be foreign function declaration, depending on how we name everything. So okay, right. This is another aspect of it. So if I do library function declaration compiled code, and then inside the compiled code, so I have function compile a function, then you call that function by default by saying library function of I don't know, the function name of blah blah blah, right?
And they're always strings. The names of the functions in libraries are always strings.
Yep.
Right. So now
pretty nice. I think this is a nice design, by the way.
But I'm just saying in terms of unifying all these things, right? If the distinction we're making is that library star functions are for library link and foreign star functions are for these sort of generalized foreign functions, first of all, this should be foreign function declaration, and this should be foreign function. Right. Which we can do.
Some sort of option on the library function declaration. It could be like foreign function goes, foreign interface goes to true or something, or interface goes to foreign or something.
No, we don't want to do that. Look, it's
this can support library function as well.
Hold on. We're going to replicate. We're going to have many of these things like foreign function declaration. We're going to have a whole zoo of these things.
The idea is that foreign function declaration would replace library function declaration. I'm just saying in terms of
could it also refer to one of our libraries?
Could do,
foreign function declaration. Could it refer to one of our libraries or not?
You mean libraries compiled with the compiler or libraries built into the kernel?
I mean, okay, so as I'm understanding it, one type of library is a standard dylib dynamic library that came from the wild. And that's what load external library deals with. A second, and its calling structure is native. That is, it's going to put a bunch of stuff on the stack according to the type declaration and do what it does.
Right.
As opposed to a library function that has been created with library function load, LibraryLoad. And in that case, the calling convention is not native data type stuck on the stack. It's instead our own structure that's been built using LibraryLink. Is that correct?
Yeah,
that's mostly correct. The only thing would be that it's right. So I think maybe let me make a right. So we have, whoops, there we go. We have library loading mechanisms. There are three similar paths. The first one is the LibraryLink path, right? Then there's the compiler path, and there's the foreign. Actually, let me put the compiler one last and the foreign function one second, so it's next to the LibraryLink one. The foreign function one. Okay, so LibraryLink, you call LibraryLoad, then you call library function load, and that gives you a library function. Okay, and then you call it. Foreign function you call load external library.
Yep.
And then you call foreign function to get the foreign function, and then you use foreign function to call it. In the compiler mechanism, you use library function load to basically do both library function declaration to do basically the first two steps, and then you use library function by default to call it. So okay, so the first thing to
not library.
Oh yes.
Yeah.
Right.
Okay.
So the first thing to note is that these two mechanisms at the top, these two functions are doing very similar things. The lower two functions are doing very different things, but the top functions are doing the same thing basically.
Okay, and the reason that the LibraryLink, just to understand again the mechanics, both of these are dealing with a dynamic library, but one of them have different calling conventions for what's put on the stack to call the external function. Is that correct? To call the library function.
Yes.
One is a very narrow. It has to meet a certain set of demands.
Which one? The LibraryLink one.
The LibraryLink one.
LibraryLink,
The function is like, you don't have to do that.
Right. But so in the future, very few people will wrap foreign functions with the apparatus to make them into library functions. Is that true?
I think that's true.
Because why would you do that? You might as well just go raw to the, I mean, the only reason to do that would be this, that let's say you're dealing with an external library and the external library is shifting sands and you want to have a consistent interface. How would you do that?
Right, but you would do that. I mean, you do that by just having a .c file that you compile that produces something that foreign function can then load, right?
So
in the same way that
a common reason to do that, by the way, is if it's a C++ library and the names all have like weird mangled things. So, or they're templates, so they have to be instantiated. So,
all right, okay. So what you're basically saying is library link is kind of old technology, which we are essentially deprecating in favor of the direct foreign function mechanism.
I don't think we want to say that. Library functions are still useful, even in this new world. Sometimes you want to write some of your own glue code. You want to write your own little wrappers around these C functions. You just don't want to go direct to metal from the Wolfram language. You know, you could use a WSTP style calling convention for library loads. That's quite convenient for some types of arguments to send it. To use a link as the marshalling mechanism for a moving argument. And the library interface has all sorts of callbacks to the kernel. You can do memory sharing with your arrays and things like that. This is stuff that you can do in the library link interface that people will still want.
All right.
Right. Like if nothing else, there's the math link. If you're doing something weird with math link and so on, you might want to use library link and be, interacting with direct math.
Why does library function load need to exist? Why can it not do the same thing that foreign function does and just be library function and do the load if it needs to do the load?
Maybe it could.
Okay.
I think it's nice to have two different functions, actually. But
well, then why don't we have foreign function load?
Well, we talked about this, right? I mean, I think we could have it, but it just means that you could still write code like this, but it would look a little ugly. It would look like that. Or it should be load.
What does the I mean, presumably, so I just looked. If you look at the ref library function documentation page, it has, you load it, and it looks like the symbolic form of library function is identical to what the symbolic form would be if you were trying to load it. It's like the same as a foreign function form. The first argument is a string, second argument is a function name, third argument is a list of types, fourth argument is the return type. So that would mean every time that form is evaluated, it would have to do a check. Am I already loaded? Am I already loaded? Am I already loaded? Which is presumably why library function load is a different symbol from library function, because you don't have to do a check every time library function is evaluated, only when it's called. So we'd have to change the structure, I think, if we wanted to avoid having to do a check, which could get expensive.
Okay, let's go back to the top again for a second. Let me understand the compiler, an internal compiler function. What is it in your table there? What is that like? Does that have the calling convention, the stack structure of a library function or a foreign function? Or neither?
More like a foreign function.
So it's pretty raw.
Yeah.
Yes, it's more flexible.
And
it would be not a huge amount of work, but probably not super to allow the compiler to call library link functions. But we've never done that.
Oh my gosh. Okay, so we've got, and why is the compiler calling its, if its function to be called is called a library function, why isn't that compatible with calling any other library function? For example, one from LibraryLink.
Right. This is sort of the argument for why I was saying, if we're going to make this distinction between library star functions and sort of foreign functions, then these should all have names like foreign function declaration. Because they're really much more like this second one.
Yeah. And just to be clear about the naming, I mean, I think in the documentation, these library functions are often referred to in the context of what are referred to as Wolfram libraries. So there's kind of this implicit Wolfram on the front of all those library star functions. It's Wolfram library load, Wolfram library function load. They're written in the Wolfram library format.
Okay.
Well, it's good that we made that distinction. Yes.
Yes, it is good. Okay. All right. So let's go through this again.
I mean, right. I think it seems like we're going to have a couple different parallel things. We just should make sure the names are it's clear which path you're on, and in the cases where you're on the same path, they should use the same name.
Yes. No, I agree. I mean, and
if I could just offer, I mean, if there's another reason not to combine foreign function and library function, which is if you imagine, if you're specifying the types of the two. So for library function, the type might be integer. But if you just see that in a signature, it's like, well, in library function, that means an integer passed through the margument mechanism. It's very specific. Whereas if it's meant to be a foreign function, that presumably is something like cint.
I agree.
Yeah,
I agree. Okay, so I agree with
Wait,
that.
can I just also say the compiler doesn't need foreign function because it creates its own, builds its own code. So it's not quite so
Right, it's
relevant.
not calling into this mechanism, but I'm just saying in terms of the naming, right? If we have right now, library functions generally refer to functions that follow the margument mechanism. Right now, the things in the compiler that we call library functions, are not using the margument mechanism. But so if we had this foreign function concept, which represents generalized native functions from a dynamic library, then that would be the more relevant name for the compiler to use.
And
but the
why
implementation will be identical.
Why are we calling it foreign function rather than external function? External function
could be. The only reason called foreign function is just because FFI is a common brand.
I kind of like the term foreign function because it suggests it's alien and that things could go very wrong.
But in a sense, every library is external or foreign. I mean, and everything and things can go wrong. So
well,
these
the
aren't
things that we
libraries.
call Wolfram libraries. I mean, maybe
it makes sense in the.
Maybe we should have Wolfram library function and Wolfram library load.
No. Otherwise, we would put that in front of every function name. But what's the difference between foreign function and external function as it's used in external evaluate?
Well, right. This is right. I mean, one of the things I was thinking of in the early days of this is that maybe this could be inside of the external function mechanism. But I think Todd had some reasons why I thought that might not make sense.
Well,
but now
I was concerned that it might not make sense.
We got three mechanisms. We've got library function, foreign function, and external function, all of which have different ways to actually call their native functions, as I understand it.
I think one question is, I mean, do we want to focus on the sort of location of the library is what we're defining it as, or its calling convention?
It's calling conventions.
Yeah.
I think we want to focus on the calling conventions because those are the things that we can't, they're fairly confusing and we can't get around having to define that.
Right. And in that case, I think foreign is more natural than external.
Yeah,
I understand, but external function already does something. External function is calling into a runtime. An external, okay, so the definition is, so I understand, external function is calling a runtime, right? Like it might be calling the Python runtime, or it might be calling a C runtime. And what is the interface for an external function into C? Or do we not have that?
We don't have that. This would be that if it existed.
Yeah, this would.
I see. So external function is really calling into a big, hefty runtime, like a Wolfram language runtime or a JVM or something like this. Is that correct?
Right. That's what it does right now.
Right. So okay,
in principle, we could maybe have something like this. But
yeah, but I'm not sure we want that. But I mean, so the definition would be to distinguish these things. External function, it's fundamentally calling a runtime, and the runtime is dispatching to whatever code needs to be dispatched to and actually executing it. Library function is calling into a created for the Wolfram library system function with the M argument wrapping, et cetera, et cetera, et cetera.
Mm-hmm.
Foreign function is going raw to the metal, putting types on the stack. Is that correct?
Yeah,
I think that categorization makes sense. Yeah.
Okay. All right. So then we've got those three levels, and we can define that. We can have a table somewhere that basically just lists those three levels, which makes sense to me.
Does this mean we would deprecate in the compiler library function declaration and library function?
And replace them with foreign function.
Yeah, I would argue you should just deprecate them and just rename them, but identical implementation.
Yeah, fine. Okay.
Yeah.
I see. Okay, fair enough.
Okay. All right. So then the remaining issue here is locations and library load versus load external library. And also the word external library seems wrong. It should say foreign library if it's going to be this family.
Right. So, right.
I mean, I would argue.
Or it should be foreign library load, really.
Yes, it should be. I mean.
But what was the argument that LibraryLoad couldn't do everything?
Well, right. Actually, that's right. Because that's where we started, was the fact that these are different paths, but they intersect at the beginning because really these two functions are doing basically the same thing.
But do they know which one it is? Do they know whether it's a Wolfram library or a foreign library?
It doesn't matter. You load them the same way.
I see.
Like you just call DL open. Actually, there's a little bit of fundamentally you load them the same way. The only thing that you might do differently is that right now, when you call library load, it uses a flag that basically says, load this into the global namespace and spew it everywhere, versus load external library, which right now is doing this mechanism where it sort of loads it more locally so that, you're less likely to have sort of name collisions. But yeah.
So,
okay.
I mean, one question, and I don't think this is a huge deal per se, but one possible difference between these two functions is that LibraryLoad intentionally calls, if a library defines a function called Wolfram_initialize, it will call that function at the time the library is loaded. Hypothetically, this load external library function might not do that. I don't think this is really a distinction worth
That's
making,
not a big
because
deal. Who's going to define that function? I mean, by the time you're already in the jungle, and the question of whether you hang up whatever, I'm not worried about that.
Yeah. Okay.
However, I do think that the term library function, which we are making a distinction between that and foreign function, it is a little bit, pulling things to say, if we say, okay, so if we say library load, both loads foreign functions. If it's a library that contains foreign functions, you then access them with foreign function. But then you just called it library when you said library load. And now we're distinguishing the library function. Well, that's okay. I think that's all right. I mean, if we had just the one library load function, and it loads an external library, and that external library can either contain foreign functions or library functions.
Or maybe both.
Is that reasonable? Yeah, so
quite possibly both.
Right.
Could you do question mark library function real quick, Christopher? I just want to point out that it does in fact say explicitly this is for loading from Wolfram libraries in the usage message.
I see.
Yeah.
Okay, fine. All right. Okay. So, all right. So then let's just understand library function load. What does it do? And is it needed?
Library function load it's definitely needed. This is the thing for loading the M argument style functions.
But foreign function doesn't need that explicit loader, because why?
Well,
it uses a different one.
It uses a different one. It needs it just as much as library function does, except that it's been consolidated. I mean, library function could be the constructor for library functions, but we just so happen to have done it so it's a separate function. We could do the same with foreign function, which is how it was before. But as we talked about last time, it seems like there's some value in having it be its own constructor, because then you can write code that looks like this.
I get it. But so why not allow library function to also be its own constructor?
I think we probably could do that. But based on what Connor was saying, it seems like it almost already is.
How costly is this? How costly is the check? Yeah, Connor's point is that you have to basically try to load it every time you get library function.
Well, why don't you have to do that for foreign function?
You do.
So
right?
Well, you kind of do, right? So I think it's probably better, and most of the time you're not going to call it like this. So I don't think there's too much value in, it's nice, but it's not like super important. On most systems, this is like pretty fast. On Mac, if you don't do caching, it's quite slow, or like it's like 10 to the minus 4.
That's not. Let me just say that is not fast. Well, like in 10,
this is at the fast. This
10
is at the
microseconds.
Values
How many CPU times run CPU instructions? Get
10,000.
No, but like a sub
20,000.
value runs at this speed. A sub value
Yeah,
runs.
yeah,
at this
fine,
speed.
right.
So it's
I'm
like,
just,
you know,
I'm just
it's
saying.
if you have any evaluated code around it, this will not be the bottleneck, right?
Okay, but
But-
so if we had
Could
a
I just
foreign
ask, though-
function load, then we could avoid this overhead. Is that correct?
Sorry, what was that?
If we had a foreign function load, explicit foreign function load, we could avoid this overhead. True or not true?
Or if you just did this, right? Add 1 equals that, and then you say add 1 of. It's because this object here, it actually evaluated. If I look at the input form, well, actually this would look a little bit odd, but it uses a data structure thing inside, which serialized in some kind of broken way. But right, so when you know it. Right. So if I take this and I compare it to, I mean, this will just be immediate, right? 10 to the minus 8. And presumably this will be faster too.
Why is that so comparatively slow?
Well,
okay.
partly because I haven't. Yeah, right.
Okay.
So right.
So there's a value then in, even if, I mean, just for people to not get confused and have slow code.
Well, but actually, hold on. Just one other thing we could do, and actually, I was looking at how library function load does this, and I think it might do something similar. So just as when you call LibraryLoad, it uses that string of the path and it puts it in a hash table. And it keeps track of basically the handle for that library. Library function load, I think, keeps track of the function name that you loaded.
I see.
And next time you call library function load, it doesn't actually have to call dlsim again. It just uses the function pointer it already had. So this could use a similar mechanism and also get rid of this slowdown.
Foreign function.
Foreign function could, right. I do still think though that writing things like this is probably the cleaner way to do it. If nothing else, because you can do this, and then that way you can sort of lazily, or you know, you can do something like this, and that way you can lazily load this once, which is kind of nice.
Yeah.
I mean, one question might be, are there cases where you might want to intentionally construct this symbolic foreign function representation where you knowingly don't have that symbol available, and you wouldn't want this to return an error, which is, I think, what it would presumably have to return now if it failed?
You mean, would I ever
Because
want to make a foreign function that referred to something that didn't exist, and I want to return unevaluated?
No, you don't want to do that.
Okay, hold on.
I kind of agree. I don't really see a good.
No.
Okay,
No,
so
no.
are you
Do that.
saying that with this string caching mechanism, I could just disembodiedly run foreign function of add 1? I don't have to set that equal to anything. I could just disembodiedly run that, and it would then look up add 1 in its string table. Is that correct?
It could. I still think it's better code if you used a symbol and so on, and it's probably more readable too. But it could work that way.
This is also similar to the way compiled code function works, by the way, and that uses various caches and things. So
all right. So then, provisionally, we imagine that this is the right mechanism, and that library function load goes away, and that library function, that you do the same mechanism for library function that you do for foreign function, and that you're setting this equal to that. Is that right? And that just
I
like
guess. Yeah, I mean, I'm a little nervous about changing library load or library function because it's sort of used in all sorts of bizarre ways.
No, I
in all sorts
understand.
of
I understand.
code.
We don't have to change it.
But-
We can leave that function, but we can deprecate it. But support. I mean,
Well, no,
okay.
because it wouldn't be a matter of deprecation. It'd be a matter of making library function evaluate, which right now it doesn't do.
Well, only evaluate in the case where it is fed, where the food it's fed isn't the food it normally has. In its
Well, I think the
normal
food it
form.
normally has. So I think the way that library function works. Well, actually, maybe I should check this before I say it.
Right. This is
I'm
what I
pretty
was-
sure the way it works is that it serializes to have an input form that looks like library
Right.
function load. But I think
Yeah.
secretly it's a function pointer.
Yeah,
And
can
getting
you
that function
evaluate the thing I
pointer-
just put in the chat?
Okay, but it's serialization. So if you actually evaluate the library function that you get from a library function load, I'm a little confused. I mean, the existing code is going to have library function load in it. And
Yes.
what am I trying to say? Okay, and that thing has an input form.
Right. And note that this input form looks identical to the call to library function load. But this input form, I think, is a lie.
Well, yeah. I mean, I think behind the scenes, it's. I mean, Tom, you might know. Is it like using like the expression hash or something, or using that expression pointer as a key to a hash table to actually get the function pointer? I assume it's doing something
Well,
like that.
it looks up. It has a hash table of. I think it looks up in the library function. It takes the library to get the functions, and then that gives another hash table. It's like a hash table of hash tables to get the actual function. So.
Right. But basically, there's a lot of hashing going on so that input form.
There's quite a bit of work to get down to the actual function pointer. Right. It's not storing the function pointer in the library function.
All right. So look.
Right.
Look.
So actually, wait. Two things to maybe quickly.
Does do.
Right. Two things to maybe quickly mention. The first thing is that this. I mean, of course, you can evaluate this, and even in a fresh kernel, this will effectively do identical things to library function load on the same arguments. It also has the nice feature that it means that it can be serialized, which foreign functions should also support.
Yes.
But yeah. Right. Okay. So this already works. It's just that maybe the error messages are worse when you don't give it the right argument.
Let me make a comment about serialization. This, just like for a bunch of these large data structure things like audio, we now have this thing that says, this is being stored in a local file. Do you want to push it to some globally accessible place? Presumably, we should do the same thing here. Because if you serialize,
would you push the dynamic library or what?
No.
Well, I mean, okay, so the question is, you send a notebook containing one of these things. You have this dynamic library that you put on your computer, right? You then send the notebook to somebody else and it won't run.
Right. So now I see where you're going, but the properties of dynamic libraries make this very difficult. For example, on Mac, dynamic libraries, depending on how you build them, have like a built-in path where they have to be, which could be an absolute path on your computer. Or if they have library dependencies, those library dependencies are often specified by default with an absolute path.
Right, and
you're also going to tell me the libraries are different for every architecture, and potentially.
Yes.
Oh yeah.
But I worry about having a notebook. I mean, we're trying pretty hard to have it be the case that you can't just end up randomly sending somebody a notebook and have it not work.
Well, so I think same with LibraryLoad and so on. I mean, and same with import. I don't know. I see this a lot like import. It's like.
Yeah, okay. Okay, no, I agree. Import is hopeless.
And we have if you wrap your notebook as a packlet, then this stuff will work.
Exactly. Yeah.
Well, does it automatically save it out if you take your notebook and you make it a packlet? It doesn't. Does it follow the dependency paths automatically?
No, you have to build the packlet with the correct files in it, but then you can distribute it to people.
But this is an argument for foreign function load, because otherwise you have code that looks like it's just going to run because it just contains this foreign function thing. But then when you actually try to do it, it's like, oh, this doesn't work. Whereas if you had foreign function load,
that's true. That's all true.
But I don't understand. Foreign function performs the foreign function load operation.
I understand that, but I'm saying that in a piece of code, somebody sent you a piece of code and it contains a thing that says foreign function. You say, why on earth doesn't this run? I'm totally confused. It looks like it's
presumably you'll get an error message that says, you'll get the same error message you get from foreign function load saying, can't find this line.
All right, okay, fair point. That's a good argument. All right, so basically what you're describing is library function load exists because of certain details of the way that libraries are provisioned, and that you don't need a foreign function load just because the provisioning works differently. Is that a fair statement? I mean, you could have a foreign function load, but it doesn't really need to exist.
I honestly, I think that it's the same it's the same situation between library function and and foreign function in this case. Like, I think I don't really see a difference between there being a foreign function load and a library function load.
All right, okay, fine. Well, then maybe we should provide those functions and basically say you don't have to use them. You could use directly inside library function, directly inside foreign function, but it will be more efficient if you use library function load, etc. Is that reasonable?
I mean, it's just weird because then we have these two things. I mean, you have library function load of args equals foreign function of args, right? That would be its definition. I don't know. It's just a pure alias.
Well, and also,
I mean, which is weird because library function
itself.
load is already almost a pure alias. The only difference is that that it has better error handling.
All right. So
right?
what are you advocating? Are you
arguments.
advocating that we basically deprecate library function load or not?
No, I'm not exactly sure what I'm advocating.
Okay.
I'm just saying that
fine.
I think that
So-
they're yeah.
So to me, a reasonable flow would be there's library load, and it loads libraries which are both contains foreign functions and library functions. Then to provision, the library function and foreign function are auto provisioning, so to speak. They don't have a separate function that needs to be run to provision them.
As
Once
in
the library
the
is
load
loaded.
function.
Correct.
Okay.
That's proposal one. I suggest that we think through that proposal. And if that proposal has a reason why it's hopeless, then we'll need that separate load function. And then the question is, do we need two functions, library function load and foreign function load, or can we get away with one on the grounds that, for example, I think it's confusing to have just one, okay? And I think if we're going to do that, I think it would be something like, provision function or something. Go ahead.
I mean, the function loading functions have to be separate. I mean, unless you're saying there'd be different usages of the same function, but that's bizarre, I think.
No, fine. I mean, I understand they have to be separate. What I'm concerned, okay, fair enough. Okay, so you're saying it's either library function and foreign function are auto provisioning, or there's a library function load and a foreign function load.
I guess so. The only thing about that's, I mean, right, here's the conflict, right? At one level, I'm nervous about getting rid of or deprecating or whatever library function load, just because, well, first of all, it means adding argument checking to library function, which, given all the weird code library function is used in, maybe could be a problem. At the same time, the alternative, or if we want to be consistent between these two, is to have a foreign function load. But I don't really like the idea of that too much either, because its arguments will be, it'll basically just call foreign function. Now, maybe we can do the same thing. Like we can do the same thing that we do with library function, where basically foreign function doesn't check its arguments at all, right? It's just a very dumb wrapper, and foreign function load does check its arguments, and that's the difference. I just think that it's not a super useful thing, but maybe we should do that just to be consistent.
That would be my suggestion. Let's move on here. Yeah, go ahead.
Wait,
Yeah, okay.
Keep foreign function load. It seems to me that we should just say we never needed library function load in the first place. So let's just make library function and foreign function both do what Stephen called auto provisioning.
Let's investigate these two possibilities. We don't know which one is going to work. Okay, there may be some gotchas that we're not thinking of right now. I think we understand. Okay, so this segment, I think we understand. So maybe we should just keep going here.
Well, yeah. So, and again, I have to go in a few minutes, but right. Okay, so maybe right. So the next thing that I did, this is also a kind of somewhat large change. Oh, actually, I killed my kernel at some point. So right. So I based on our discussion last time, I added some typed pointers. So last time I was sort of arguing why, in the current system, there was only opaque pointers, but now I have some typed pointers. And the reasoning for this
is create buffer. Is that your?
Well, we're going to kind of get to that, right? So there's a whole zoo of functions, which are sort of the functions for creating inputs for, functions for creating inputs and interpreting outputs from C, from foreign functions, right? Foreign functions
Maybe it should be called create foreign buffer.
Maybe, yeah. So let me show maybe the zoo of. Well, okay. So there's a whole zoo of these functions, which I don't think we're gonna have time to go over all of them right now.
I noticed a comment on the live stream about resource function failing and giving a failure object that then gets confused when it is fed sub-value looking arguments. Let's bring that up in the LCC meeting. Okay, separate issue.
I assume it's this case. Oops.
Yes, it's that case. Yeah,
actually, that's not too bad because it said if that returned a failure object, it would be more broken. But yeah.
Right. Okay. Let's bring this up in LCC.
Okay.
This is a separate discussion. Okay.
Right. Okay. So, right. So basically, the point is there's a whole bunch of these functions. Right now, I've been using the term buffer. That's kind of a weird term to basically mean pointer to some memory. Right. And there's a whole bunch of these functions. The main reason why I added this raw pointer type was because all these functions that take a buffer, pretty much all of them that take a buffer have to be told what is the type of the things
otherwise
in
they
the
don't
buffer.
know the stride of the in
right,
the buffer.
They don't know the stride, and sometimes if it's an array, they also need to know how long the array is, but it's not always an array. So the idea is if you have this raw pointer type, then they don't have to ask you about the type every time. And most of the time you do know the type. And if you don't know the type, then I have it so that if you have you can say raw pointer of another raw pointer, and you can
what about
cast it.
What about casting? Yeah, I see. So this will cast it.
Well, it does. It casts it by just telling it that the type is different.
Right, which means it has a different stride. So right.
Yes. But this is mostly useful if this thing is like an opaque raw pointer, which is sort of like a void star. So if you have an opaque one, you can tell actually it's specifically an array of integers, and now you can go.
I mean, I can imagine weird cases in which you want to read floats as their bit pattern and so on.
Sure, you could do that with this. Right. So I guess the right. Okay. And one other thing about the pointers, although this is sort of a question here, but I think I know what it should do. So one question is how much sort of type checking should it do between pointers? So my sort of argument was if a function expects an opaque raw pointer, you can give it any kind of pointer. And if it expects a pointer with a specific type, you have to give it a pointer of that type. Maybe also if it expects a specific type, you should be able to give it an opaque raw pointer, but just no other raw pointer of a different type, if that makes sense.
Yeah, I think that's right. I mean, because an opaque raw pointer, as its memory will be sliced up by the caller.
Right. So maybe an opaque raw pointer has the type of all pointers.
Yeah, it's a union type of some kind.
Pointer.
Yep.
Yeah. Okay. So if you're expecting a pointer to an integer, you can be given an opaque raw pointer and you'll accept it. You don't have to explicitly tell it.
But then you do the slicing into integer strides.
Right. Okay. Fine. I think that makes sense. Right.
Now, okay. So let's talk about the word buffer. And
right. So actually, the first thing I should say about the word buffer, okay, because this is there's a bit of a relation. So okay. Right. There's functions to raw pointer and from raw pointer in the compiler, which are functions that
I'm just seeing the function unload external library. What is that? Why isn't it just called unload library?
Well, we already have unload library. This is just to go with load external library. Or library unload. Right, which we're now saying should be, I think we're now saying that, or actually, I guess we didn't totally resolve it, but at least one of, right, you're going to load libraries always with library load. There is no library load external library. And then.
Which means there's a library unload as well.
Yeah, which there already is.
Okay. All right. Okay.
Would that distinction potentially be a reason to not have foreign function and library function auto load the library? Because it kind of, if you imagine you have an explicit unload library call, but then you happen to have a subsequent call to library function that just silently reloads the library when you didn't want that to happen.
Well, also you have
Well,
no way to
let's-
even have a pointer to the library to unload it if it was implicitly auto-provisioned.
Well, no, you give it a path because remember
see.
paths just do this.
Why do you
from a
unload
secret
libraries?
table.
What's the point of unloading libraries?
I see little point.
No, on Windows, you need to do it on Windows. Like you might need to replace the library if it's loaded. You can't. Windows won't let you overwrite a file that's a library that's open.
What do you mean by replace it? You mean
So suppose you're developing a library link library, you compile one version of it, load it,
I
test
see.
it, it's wrong, you make a fix, and you don't want to have to quit your kernel section. You have to unload and then reload.
On Windows.
Right.
Okay, yeah, I didn't know
Exactly.
Windows had this problem.
Yeah,
Yeah,
I've gotten
Windows
bug
is
reports
very-
about that.
Yeah,
but we could
very
easily have it be the case that if you do a library load on top of an existing library, that it behind the scenes unloads the thing before loading it. Why wouldn't we do that?
No. That's not the time you do it. It's when you rerun your compiler outside of, your Visual Studio, outside of.
Oh, you mean you call unload before you overwrite the dynamic library file?
Exactly.
Because it refuses to overwrite the dynamic library
It
file if the library is
refuses.
Yep.
It refuses to
Ugh.
overwrite it
Ugh.
If it's been
Ugh.
loaded, I see. Yeah.
on Windows.
Ugh.
Yes.
Okay.
Okay. Right. Next.
Yeah. Okay.
Yeah. Okay. So
All right.
and again, I have to go in just a moment, but I guess the basic thing, and this is maybe we should spend next time talking about is the design of all these functions. There's a bit of a relation to to raw pointer and from raw pointer. Like there's two of these functions that are kind of analogous to these, but there are also a bunch of functions that don't have much of a compiler analog, although these functions probably could also be imported into the compiler, because basically the way you do these operations in the compiler is usually with this general function called create type instance, which does all sorts of stuff. But like you might do something like, write this, and this is kind of like list to buffer of 1, 2, 3. I think here I have to specify that
I think we're running out of time, and
type
you're
two.
going too quickly for me to understand.
Okay, fine. Well,
So
basically, there's all these functions. They need designs, but also the there's some relation to a couple things in the compiler where either the compiler should sort of import some of these symbols in order to be consistent, but also there's a couple of existing symbols in the compiler that maybe this should inherit from. But
Okay, question.
Yeah.
Do we have a big queue of libraries that are waiting to be linked? Just so we make sure that these mechanisms actually cover the things that actually happen. Like that refprop library, for example. Is that one that is plausibly going to fit into these mechanisms?
I still haven't looked at that library. I think there was a link to that library using the compiler, and this covers kind of all the same stuff. I'd also say that this covers almost every behavior of dynamic libraries. I think maybe in fact, I think it covers every single behavior. The only thing I think it might not really cover is globals, but it probably could.
Okay. All right. You need to go. We should wrap this up. We should set another set meeting. It's going to be presumably need. It looks like there might even be time tomorrow. But are we going to need another hour and a half? We probably are on these.
I think so. Yeah.
Okay. All right. I look forward to it. And let's wrap up for now. Thanks to folks on the live stream. See you all soon.
Okay, bye.